Boom. She's electric and she's driving. Put on my full safety regalia because it's time to finally turn on the high voltage switch, and if there's a problem, it will all explode violently in a fireball of lithium and human hubris. But I'm hoping that it'll just send regular series voltage to the controller, and then I can measure it through the software and then commission the clone file in the TAU software. And SmartView, that's what it's called. Here we go. I thought you should witness it either way. A lot of 12-volt systems are working very nicely. Stuff's operational. I adjusted the temperature of the probe here because last week when I first put power to it, we were having a heat wave. It was 100 degrees outside and the sun was right on the sensors, warming everything up. And sure enough, the fans were turning on as they should. So I pulled the fuses on the fans so that they don't turn on every time we go to test other things. I'm going to be programming the files now for the computer. But I wanted to show you before I do that all of my high voltage stuff is disconnected. They say if you're going to work on anything, do it with one hand. Don't complete the circuit through your body by using both hands. That as far as high voltage stuff is concerned.
You must create a pathway from your fingertips, up your arm to your shoulder, then down into your stomach. You must not let the lightning pass through your heart, or the damage could be deadly.
The pre-charge lug for our high voltage for the controller is running through the main K1 harness. The K1 harness is now plugged in because everything else is sufficiently tested. We have the in and the out side of our controller coolers, the temperature sensors for them that live down here. Each one determines a different thing. One's for the gauge cluster, the other one is for the electric fan, which is controlled through the device right here. And it's got its own relay. And then all of our 12-volt stuff that I added, I'm gonna go ahead and plug in the vacuum pump because I wanna show you how quiet it is when I turn the key on. It's pretty good, right? Nice. So it'll stay on for about 50 seconds, or I'm sorry, it'll stay off for about 50 seconds, and then it will cycle back on because there's a leak in the buttons because these buttons aren't designed to be leak proof. This whole system runs on vacuum controls. I even went through and tried to seal the controls up with some putty, but they won't. The buttons themselves have some air leaking through them, and the reason they set it up that way is because when the engine is running on an internal combustion engine, it is a constant supply of vacuum, which is where check valves were important, but the check valves are mostly to keep this vacuum chamber that is the brake booster with its own emergency supply in case the engine power is cut off. You have 3 good pumps, that's enough to get you stopped. 2, 3, 14, 15, almost 15 seconds of refilling time every minute. It's a pretty inefficient system, but that's what Volvo gave us. We can always seal off the inside chamber so that it doesn't have as much of a leak, and maybe do like a toggle switch to allow vacuum controls for things if you really need to do floor and defrost settings. I like that there's an LED light to show you if the circuit is open and voltage is not flowing through each of the fuses. You good, bro? And I have to test all of these circuits. We have our vacuum pump, the high voltage relay, the K124, that's a 12-volt signal for the system, and K124 is another blue wire just right inside of the main 35 pin connector. The water pump, which is actually pumping right now. You can't hear it at all, but I can feel the buzzing of it. I wonder if I open this, if it's gonna spill or if it'll show you water. Really nice how quiet the Davies Craig pump is. Very cool. So water pump is good. That's only 3 amps. I feel like 15 amps is too much for the vacuum pump, but I'm gonna confirm my instructions there. And then the 7.5 amp pusher fan, that is the one that is disconnected right now. And the very last one there is the low voltage cutoff relay, the BMS diode, and the DC to DC trigger. There's 3 things on one 5 amp connection because the DC-DC trigger, oh my goodness, he was the tiniest wire. It was like a 24 gauge, really small. It's probably half an amp at most signal. EV West gives you one null modem gold cable, DB9 female to female, 6 foot long. The other one is the USB 2.0 to RS232. It's an adapter with jack nuts and a micro CD, which is the USB to serial A converter installation software. However, that same software is available over here on the website, so you don't have to worry about finding a micro CD drive or any CD drive. When was the last time anybody burned a CD? Well, think about this. The last time you burned a CD, you didn't know it was your last time burning a CD. I like to think I still have one more in me, though. I'm having to use a Windows computer for all of this stuff because my MacBook is not playing along with the SME system SmartView software, and this is all PC stuff, and that's too bad. Cool. So now we're on step 10 of the startup procedures. The K3 port on our controller is labeled right here. K2, I'm guessing, is the battery cables, which would be these failures. K1 is the 35 amp there. Another thing to note, keep all other USB devices disconnected while you're working with this one connection. So with the key on, it should pop up to another screen. There we go. We have some communication. We are programming. Woohoo! It's moving pretty decently here. Install your motor's downloaded clone file by clicking on Manage Clone and select the left icon to load your file from the archive to the inverter. Manage, restore and clone firmware update. This is where we need to be. So you can download these specific clone files for this. Your clone file must be calibrated to your motor before use. With TAU SmartView and home screen active, click Monitor Real-Time Data Inputs. Monitor on the throttle pedal. I'm going to be using my arm here. Be pushing this all the way in, and we'll see which input it is. It should be input number 1. Look at that. I'm halfway through, and I'm all the way through. And yes, it goes all the way to 4445 millivolts and all the way off 943. So it's 1 to 5 volts. That's great. That's exactly right. Yes. We are now to step 19. Turn off the key switch, leaving the high voltage supply disconnected. Now we can connect the UVW high voltage leads. Make sure the wheels are suspended from the ground. So the big old red switch is right up front here. It's the easiest access point to it. Please let it work. Okay, that didn't make any noise. That's good. It's on. Sweet. Now I'm going to turn the key on and see what happens. Okay, nothing blew up. I have the fans disconnected because it's not hot enough yet to warrant turning them on, but the other one is set to a thermal probe, so if it gets too warm, it'll turn on automatically. The controller is seeing power. I have to figure out what the system voltage is right now. Let's go through and make sure we're within our absolute minimums. Our hyperdrive needs to be between 73 and 184 volts. That's the absolute minimum and maximum. I'm guessing we're between those amounts. It does no good to measure the voltage at the inverter for B+, B- because B+ is currently closed off at the contactor, so I had to check the voltage from the other side of the contactor. I believe that's X1 is the terminal and this is X2, something like that. But where all the wires go directly from the switch and the battery circuit, the other side goes to the shunt. So I measured from the shunt to this guy, 153 volts. We're well within our minimums, baby. Let's go ahead and commission the spin sensor. And we'll get some motion through that motor finally. Right now I'm trying to diagnose why I'm not getting green lights on something. All these inputs here, K1 through 9, some of them need to be green, and it was these steps that I thought I was getting green lights because there's light green and dark green. I sent an email to Michael at EV West, and he's also very, very good at helping me see things that are pretty obvious, glaring stuff that's right in the way. So I didn't install the firmware correctly or the clone file correctly. I'm gonna go back a few steps, reinstall everything. which means unfortunately I have to undo the Loctite on the motor controller and the 3 phase leads going to the motor itself. That's a shame, because I did a really good job attaching everything, so I guess it just shows to go ya. Don't make your permanent attachments right away. You might have to go back. OMG, today's the day. We're gonna put power to this motor, and it's gonna spin for the first time. Here's the steps moving forward. One laptop here for writing, because Windows computers are slow, and then this one here is connected to the software through the serial cable. And the battery cables are connected, the switches are turned on, and we actually have 0 faults right now. Look at that. We have a pure, perfect monitor. And let's go to our monitor page. We want real-time data. We got our inputs to be green, bright, bright green. So how is that? I just went through and reinstalled the clone file and made sure the firmware was correct. I'm gonna go hit regen braking. You'll see profile 2, which is number 7 on those boxes light up. Boop. Regen braking is on. And boom, the circuit works. So the funny thing about my regen braking switch is while I wanted it to send power to the light at the bottom as well every time the regen button was initiated, because we're dealing with such small voltage values, we're dealing with under 1 volt for the signal to be activated, it was getting continuity through the filament and keeping the switch closed the entire time. So it doesn't matter what position I would put this at. If this wire was connected here, that it was enough to transmit the power through. Within 90 seconds, I'm gonna go to the screen. I'm gonna hit commission sensor. It will spin slowly for 1 minute. Once the commissioning is done, the system should be fully operational. You can now attempt to spin the motor. And if the motor has got a blocked rotor, maximum current and 0 RPM with possible high frequency noise, switch off the controller. This means that the encoder wiring or the motor phase leads are wrong. Please check them. It's nice that you don't get a message that says, oh, if you mix up the phase leads, there will be a sudden explosion. It's just telling you, you could do some work, you could get things wrong, and you'll get a high-pitched noise, or it won't spin, or it might spin too fast. It's not gonna blow up on you. So that's really great news. But I have to clarify, it doesn't mean that if you were to cross your wires or touch them together, I mean, you could probably switch UVW and there'd be some weird issues, but if you were to touch battery positive and negative together, yeah, there'd be some sparks. Oh yeah, there'd be some current. It gets spooky then, but generally they're saying, it sounds like people have switched UVW in the wrong order and it hasn't destroyed everything catastrophically. Motor and control, spin sensor, configure, motor and control, commission spin sensor. You're booting me back to the home page again. Why did you boot me back to the home screen? That's annoying. Time to investigate. Nice thing about daytime support from EV West is that you could just reach out Monday through Thursday. So I was just on the phone with Michael and he said, go through and reset all your connections. All the wiring should be nice and tight, and sometimes you just have to disconnect and reconnect USB ports, etc. The software is a little bit buggy. The manufacturer knows that. They don't have a fix for it. But try that and be patient with the software. Give it 2 seconds every time you click between pages. So that might be exactly what we need to do. I'll go through and I'll disconnect everything and reconnect everything, except for the high voltage lead stuff. That'll be separate. High voltage on, 12 volt on, connection connected. Good. Key on, back to 0. There we go. We're going to system for motor control and home. Okay, let's disconnect some more connectors and see if that helps. So I think I was able to trick it into doing the commissioning. The trouble is you have to do it within 60 seconds of the key being on, and I was very close to that time, but what I ended up figuring out is that if you were to put the car in gear, spin the back wheels, it gets the motor spinning a little bit, which changes the sine and cosine values because it is operating on a wavelength with the rotations. I would turn the key on, go to that page, it would go away, the motor and control page where the button is for the commissioning. And as that disappeared, I would then quickly go and put it in 4th gear, spin the back tire a little bit, back to neutral, and then go back to that page, and it populated. That's great. So commissioning is done, motor spun. Let's put some pedal to the metal, huh? All right, go ahead and check our speedometer now. Now, I've got a serial to USB cable setup, which goes all the way up here into the BMS controller. You can see the red light blinking. So wherever that's set up on your car, you want to have good access to it, because that's where a lot of our programming is going to be done for the BMS. And right now, our startup stuff is talking about battery protection. We need to do the undervoltage, overvoltage, and current cutback points. The interface is used for configuration and debugging. It's not required for normal operation. The firmware supports diagnostic commands to verify proper hardware operation and wiring, to trace CAN messages, and to receive cell statistics. It's really neat how basic the configuration is here. I typed in show map here, and it brought up LTCs 1 through 4, our groups, our cells. It confirms that I wired it correctly. And then I typed in show cells, and it gave me all of the values of each cell. And then there's the line for me to type in further commands. Other than setting the high voltage and low voltage threshold values, it is not necessary to do any additional configuration in order to use the BMS. I discovered a little problem with my thermistors. Everything was working out just fine. LTC 1, thermistor 1, 2, 3, 4, and then it was registering 5, but 1 not connected. Everything else was good, and then it was just showing dots, 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 which the instructions here told me that when dots are listed for the thermistor, that means the thermistor value is shown as blank. There's not registering anything. If there's a dot, it's there, but it's not enabled. If it's NC, it's enabled but not connected. The pinout of this connector is the same on both sides, which means thermistor 1 is to the right. So 1, 2, 3, 4, 5. And on this side, 2, 3, 4, 5. Great. So I labeled this correctly, but then when I went through and made my thermistor connections, I went through and wired both sides of the same side. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then you go to plug this connector in, and it's backwards on one side. So I'm gonna have to unpin this connector and repin it in the car. We'll see what that involves, because they're very, very tiny pins, but I did buy a kit for this exact reason. Success. Let's plug in the laptop and see what we get. All right, key on. Contactor clicks, open up PuTTY. Select BMS, hit open, boom. 1, 2, 3, 4, 5. 5 is now showing as not connected, and 1 is showing as something is there, but it's not enabled. So I believe it should be as easy as enable TH, and that thermistor is enabled. Okay, now we can go to show TH, and I wonder if I will have to erase number 5, or it will be automatically erased. Number 5 is automatically erased. We have corrected my wiring mistake. Yay! So that's it. Our BMS is set, and to confirm everything, once you hit lock, L-O-C-K, boom. Configuration locked. Solid, green, blinks, everything's good. Connections are nice, out of the way. And I can go ahead and put the covers back on after we do our first test drive, which is coming up pretty soon. My TBS Electronics 5-to-1 prescaler is not working. What this does is it takes the high voltage from the high voltage battery and it turns it down to a lower voltage where our battery meter can communicate with it, so it's not going to fry out the meter, so it does a 5 times reduction. Inside of here is a little fuse. This fuse is like 0.25 amps in capacity, and sometimes when they blow, they still look visually good. I went ahead and replaced the fuse and checked both of them, and they were both good. I don't know what's going on, but I'm not getting power from it. I double-checked our connections. Everything's looking fine. I think the next thing to do is try another TBS Expert Pro and see if perhaps this one got damaged or cooked. And anytime I do this change of the guard, I have to make sure to disconnect both batteries, the 12 volts and the high voltage. The replacement TBS has a bigger printout on the instructions. That's really great. Confirming here the connections, we've got our plus and our VM. I think VM is voltage main battery and VA is voltage auxiliary battery, which is optional. We're not dealing with that, so. The prescaler is just in line with these two wires because our main battery voltage is exceeding the 35 volts that this guy can handle. So just a reminder, do both instructions, and it's nice that they're both through TBS and they're formatted the same way. And then of course, twisted pair to the shunt, we know the rest. Still nothing. Turns out our fuses were popped. Funny thing is, these fuses, these tiny little baby fuses, they handle 0.25 amps and that's their maximum. something high voltage side, because it's not galvanically isolated, something in our high voltage system, anywhere in the system, is getting contact to chassis, and it's supposed to be separate. So what could it be? There's a couple options. The DC to DC converter, because it's something that crosses between the chassis side and the high voltage side. The DC-DC converter could be seeing a short somewhere in where the negative side of the high voltage is just making enough contact, or the charger could be another culprit. And while it could be fun to go through 18 different fuses and try to diagnose the issue, I think we're gonna have to start by checking all these systems. But more fuses are on their way because we popped both fuses. Everything's so sensitive. Let me show you. And Michael reassured me that these fuses are usually the culprit. It's never the hardware inside of our prescalers, because TBS has been a very good company for them and they've sold hundreds, if not thousands, of these units. Here's the funny thing. When I was measuring the resistance, I was holding the fuse and putting it like that and holding both sides because they're so tiny. And the human body is a conductor. So I was registering millivolts, which to me was like, oh, very, very low resistance, which means it's free flow electricity. But then when I went through and isolated my hands, so I was seeing 0, open limit, which told me that my fuses were blown. And that's the funny thing about these low amperage fuses. You can hold them up to light and they will look fine, but the limit is so low that it's somewhere in those metal ends that you can't see. So I just finished adding a relay that when this low voltage cutoff relay gets a ground signal, the wire from here runs to another relay, and that will trigger all of the dashboard lights to tell you that there's a big bad warning instead of just the one light there at the buzzer. So let's test it out. Boom. So that's what'll happen if for some reason everything goes wrong and the car is at very, very low voltage. Now to check this circuit, I'm gonna have to program my BMS with the USB and go through the software and just set the parameters a little bit higher. So if my low voltage minimum, absolute minimum is like, let's say 120 volts, I would test the circuit by maybe setting it to 130, driving around till it hits 130, and then seeing if the alarm goes off. Final step in the tachometer install, there's a couple of procedures here. We're gonna go into our TAU software, we're gonna enter into the configure system, CAN network, select my role CO node. There. Yes, I really want to key off. And we're rebooting. And we're checking for the green thumbs up in the lower left-hand corner. That will... Yay! Now, let's see if our tachometer works, huh? Here we go, spin, spin. Tachometer is working. So once battery mapping is all taken care of, we're going to move along to throttle mapping. Throttle mapping has preset values. It says here that the Hyperdyne clone files come pre-programmed with the throttle map for the Prius Hall Effect pedals assembly. That's pretty good. But if you do need to go and adjust things, there's a lot of options here. I made sure to note down our values from resting position to wide open throttle. Of course, you want to check that with the high voltage disconnected, or else you'll just be spinning your wheels madly, and that's not really good for anything. And then there's, if you have a brake pressure transducer, you can adjust the regen through the pressure on the pedal, the brake pedal. There are 3 regen values set on 3 different profiles. Profile 1 is just the regular forward. Profile 2, some regen, you can do that by a switch or something else, but in our setting we have a switch. And profile 3 is high regen. We're only doing profile 2, and you can actually adjust the regen values in the software, because I want to do profile 2 for high regenerative braking. But I also want profile 1 to have a little bit of regen, so we can make it feel kind of like a Prius, where when you're off the pedal you're coasting and you're not just freewheeling, you're actually able to get some regenerative braking, because a lot of this will be city driving where you want to get some power back and not use the brakes, so we can maximize our current going back into the batteries. I basically left it all alone. I just added the value for profile 2 to be 28%. But there's full instructions if you want to do one pedal driving. The reason I don't want to do one pedal driving on this is I don't want to stress the cradle too much. because all that torque is going to just be twisting on the Hyper 9 bracket, and our bracket is basically a rubber clamp around the motor, and you know, anything we can do to minimize the actual motor twisting a little bit. So just to keep the stress point low, I'm doing a maximum regen, I think, of 28%. We'll take the car for a drive later, and then we'll be able to determine if that's a good amount. And the next thing here is there's a couple of digital outputs. The X1 controller can energize the coil of a relay, which is not included, using generic outputs for 2 of the following functions: a warning alarm, brake lights, deceleration lights, motor and/or controller cooling. That's really great. EV West gives you instructions for deceleration lights, and they give you a nice wiring diagram here. But I got very excited looking at the possibility of doing a cooling fan. The cooling fan, they even give you suggested temperatures for it, which is going to be really nice. The other reason I want to do that is that currently our fan is just set to be on constantly when the key is on. And that's not a great use of power, because especially in the winter months when you're moving forward or just driving, coasting, it's freezing outside, you don't want the fan on constantly. So we'll save ourselves a couple of amp hours here and there by wiring the controller. But there's a thermal shutdown rate for the controller, 95 centigrade, and a thermal shutdown of the motor, 165 centigrade. So if it does get too hot, it'll start to limit output and then eventually shut itself off so that it won't destroy itself. I also have a second fan. Well, this one now is going to be controlled by the controller internal probe. This one is set to a programmed relay right here, which is for the air conditioning system, and it's plumbed into the controller as well. So if any time the air conditioning is on, or if the controller temperature reaches a certain amount, I've got it set somewhere at like 160 degrees, that big fan will turn on, and I can adjust it all the way down to 85. EV West sent me 2 replacement fuses for the TBS prescaler. I'm nervous that they're gonna just pop again, but I disconnected the DC to DC converter from high voltage, and I disconnected the charger from high voltage, so we've isolated a few circuits. Hopefully that's the case. I'm gonna connect the fuses here, one by one, the high voltage fuses, and we'll see if this little guy pops when I plug them in or not. Number 1, the prescaler fuse itself. We have power to the gauge. I'm also wondering if perhaps there was like static electricity in shipping, built up some static, and then it grounded and then shorted the fuse with 0.25 amps. I'm so grateful to EV West for tech support, because it's every day when I'm encountering some sort of question, they can say something like, check out our website. We have a PDF. If you search BMSC and you go down 3 files, you'll see the recommended parameters page. And I was like, why does that look familiar? Oh yeah, I have this saved. But it was 2 years ago when I downloaded every PDF I could find. And so I didn't consider that. But we need to know our values so we can set things like high voltage cutoff, low voltage cutoff, the clear. One of the most important ones was a command in the BMS for closed loop on fault or loop OC. Open collector is a transistor type output that will pull to ground. So we use open collector because if there's a single fault loop, and let's say we want the charger off, we will still need it to work in a low volt error. So when you have like a low voltage cutoff with an open collector, it allows the charger to still run. Open collector allows us to have essentially one thing that says, oh, we need to turn the charger off, and another thing that says, all right, now we can use the charger to correct that fault, rather than having it permanently disabled. So the faults aren't fighting each other. And the website having this full list of PDF files, they're all based on different items. So as you're shopping for a certain part of the catalog, then the appropriate PDFs will be listed there as well. These are so helpful. And this one's new for 2024, the 7 module configuration, and they also have one up to 10 and 12 modules for the 120 volt 6 module. Wow, imagine how far you could go with 120 volt system with 12 modules. This has got to be 300 miles perhaps? Whew. We're here in just the single 42 in series, 175 volts, I guess is nominal voltage for us. 2 enclosures, 3 in the front, 4 in the back, the BMS labelings, the thermistors, etc. Very nice that they keep updating things like that. Pizza is getting easier to make every year. TBS Expert Pro has an internal relay, and it's before the BMS was used, when it was just the AVC2, this was an alarm to open the charging circuit and stop charging if the charger itself was out of control. I think they said you don't want this to control charging, but it would be an overcharge lockout. It would be an overcharge protection. Now, layer of security was great, but since we now have a BMS, we have alarms available. And you can program it to be anything you want. You can just have it be a charge reminder. You could have it be a low battery reminder. You could have it be the check engine light if you want to have a third seatbelt in your security system, because we have the charger seatbelt 1 that's programmed. We have the BMS loops here are all low voltage, high voltage protection. That's seatbelt 2, and this could be seatbelt 3 if we really needed it. That's all to say that I'm gonna actually put these to use because there's this beautiful light on the dashboard from Volvo called CH. I don't know what it's for. Maybe it's emissions related, but if we ground the wire, that light comes on, and I'm thinking I could run this as the ground loop. Our BMS software is set up. This is the final configuration. We have all of our values input. You can see behind me there's only one dashboard light that comes on now when when the key is turned on, and that's the parking brake light. And that's because the low oil pressure light is now set only as a warning. I'm at the point now where I can clean up and finally do the heat shrink on the X1 K1 connector and start tidying up bits and bobs here. Oh, and the horns. Nice. Cleaned out both sides. Everything's beeping and bopping. Woo! I know we've been looking at this thing for years, but it's actually going really well right now. I'm testing all the systems. I've hooked up all of our 12 volt systems, all of our high charging, high voltage systems, and it's good. I'm just trying to get the voltage down so that we can trigger the alarms, and you can see the real-time reports on the LTCs and into the BMS. When I push the pedal here, because it's right on the threshold, it's going to populate all these messages that say in LTC, because we are right there close to where I set it. And you can see that everything's 5.7, 5.6. I try to get it down to 5.5. So when I push the accelerator, it's going to populate LVC, and then it's all going to populate OK messages, because the voltage will dip down momentarily. Yep, so acceleration in LVC, deceleration, everything goes back to OK. So if I didn't set the timer on the BMS, every time I would push the accelerator on that threshold, it would beep at me. So it's smart to have a 10-second delay for things like regenerative braking to kick in and hard acceleration to finish. 5, 6, 7, 8, 9, 10. Yes. Very good. Okay, low voltage alarm works. All of our circuits work. I can go ahead and set the parameters to their final driving ones, which will be the lower voltage, not where it's at now, just for funds. This is a huge moment for me. I'm gonna finally heat shrink the K1 connector at the controller, which means all of our wiring is finished. 2.5 years. I let myself dream just for a moment about how I'm gonna write an article for the Volvo Club of America magazine, Rolling Magazine, and I'm gonna make a full, beautiful display of how the car looks when it's finished, and people will read it. And perhaps you're here right now because you read that article all these years later, and you're watching my videos for the first time. And welcome. And that's one way to keep myself accountable to actually writing that article. So again, I just time traveled. I can't wait. It's gonna be so exciting. And then the funny thing is, at the end of the article, I'm gonna be like, by the way, whatever you think it's gonna cost, double it. By the way, I have to do it all over again now for car number 2. But it's exciting to think that I'm almost getting my life back after 2.5 years on one car. It's huge, but it's huge progress, and it's a huge achievement. And I'm very proud of my work, because today showed me that everything I did is working. Everything's operational, in order, no fires, no short circuits. Life is good. The work ain't over, but take the W where you can. This is a little tidbit. I don't know if I mentioned it before, but the K1 harness is in this like unfoldable loop where you can get access to the wires, but I wanted it to be smooth for this portion because that doesn't really like to curl around or make turns. So I ended up putting a smaller section here, which is just solid all the way around. And then I layered the two of them up here So I have this nice fat piece of heat shrink that's gonna go forward and attach to them, and then this little guy sits in the front because that's our pre-charge circuit wire. So it was just that it's a nice little detail I have because it keeps this part looking quite smooth, and I'm very, very excited to finally clean up all these and just make it look smooth. The wires here are about as good as they're gonna get. There's just a lot, and I can do a few more zip ties here and there, but for the most part, it's about how it's gonna be. And there's only one that crosses over, and that's the washer pump here, unless I decide to cut it back. Something I want to do, but if it really bothers me, I can. Otherwise, we'll just have to live with this single blue wire, blue and yellow, kind of jumping the gap here. And then I gotta do something decorative for this plug. These were just holes in the fender for whatever reason. Somebody put an accessory bracket there, or maybe it was the washer bottle bracket. I can't remember, but they don't look like Volvo holes. They're a little oblong shaped. We'll find some decorative plugs. Maybe I'll just paint them the blue color. I've got a little bit extra paint. Yeah. Wow, I'm letting myself dream. Okay, gotta get to work. Sun's going down. Sun's getting real low, buddy.
Sun's getting real low.
You know, in my mind it was a lot better, but it still ain't bad. LED headlights. They sit there. This folds over. We have a nice seal on the backside. This is our heat sink for the LEDs because they emit heat from the backside, unlike traditional light bulbs. Got to make sure the orientation is correct so that it shines the light downward. There's little shutters on the bulb itself for the low beam versus high beam. Might have to add a relay because we have a bulb failure light that may be triggered by the lower resistance of an LED bulb versus traditional incandescent. To save functions into our internal memory, we need to hold down the menu button again for 3 seconds. Everything is saved. Synchronize is still blinking because it wants us to charge. Hello. So that's it. We're basically set up with our TBS. Everything else is in order. I am ready to do the first test drive. So the next steps for me are to lower the car, charge it fully, which will help synchronize the battery, drive it. The gauge will flash the light, the amber backlight, when it's fully charged. And then we're gonna go and drive around until it hits 5, 4, down to 0%. You wanna check all of our voltages and then monitor as we get down to 0 that our charge light triggers when it should at about 10%. And then as we reach 0, check our voltage reading to see that we still have usable voltage, because if we drop below our bare minimum that we aren't able to operate it, which I think was 134.4, when our gauge reads 0, we should still have a little bit of reserve capacity. It's like emergency fuel to just get you home. So at the gauge 0, it should be reading something like 138 volts. And then when it's actually truly at 0, it'll be down to like 134. And this is just so that people can get in the car and treat it like an iPhone. You know when your batteries, you can still be operating it safely if you're down 10, 9, 8, 7, 6%. You just know it's not ideal, but sometimes you're in those situations. Future diagnostics are now going to be done through voltage and current. So everything needs to be synced correctly to the gauge for that reason. We're finished. It is 4:20 p.m. Time to go to class. Got my acting class. I'm playing a Chicago cop. Me and Denny, maybe we don't exactly see eye to eye here, but Sergeant Dickerson says we better schmooze up to the department heads if we want to get to the next round of detective promos. That's what I'm working on tonight, so we're done with car stuff for the day. And I will see you when we have our seats back in and this thing is ready to go for a drive. I'm not really dressed for the occasion, but I wanted to give you guys a look at this car moving under its own power for the first time in 2.5 years. Here we go. I'm going to be programming the front fan to turn on with a temperature setting instead of a constant, which is great. As soon as you press the throttle, the motor kind of like judders a little bit because the magnets have positions. So it's not like a smooth, big round magnet, it's multiples. So you kind of just feel it like back over here, get a better view of things. These doors haven't been open in 10 months. We're putting in some fancy gadgets on the glove box. There's an Anchor power brick. There's our power inverter right there. And the Anchor thing's gonna connect here to the 120 volt inverter. We have ourselves a voltage prescaler there. The tachometer interface is there. The main contactors are all there. The bottom fuse right now is open for the air conditioning because we're not using AC yet, but I could close it. There's no reason to leave it open right now. Everything's working well. It's a little crowded in there, as we've seen in some of the videos. Yeah, we got a lot of space here for activities. Of course, the spare tire, we want to prioritize keeping that in its place. We have the charger here. And one of my next things to do is to charge it. Now, here's the thing. Let's do this live because I have everything set up where if I plug this in, it should just start charging, right? Because right now we're sitting at 150.7 volts. So let me do that. Let me plug it in. We'll see if we get some charging going. And if not, there's a problem and I'll dig into the circuitry later, but wasn't planning on doing this part. Here we go. We're plugged in. I'm not seeing anything yet on the gauge. Oh. Ah! The fan just turned on. We're charging! Yeah! Oh my goodness. Oh, I'm so happy you guys are here to see this. I was so nervous that any number of things could go wrong because you're dealing with all new systems here, Dave. Oh, yes, dude. That's so excellent. We're about to reach the checkpoint, which is car number 1 being completed. 2.5 years. It was May of 2022 when this thing pulled into that garage. Let me tell you, I'm so much happier with this side, just FYI. So I think I'm gonna let this charge for a while until the seats are put in, the front seat, just the driver's seat. It's brand new leather, so I gotta protect it because I'm dirty. And from there, we'll put the mirrors on. We'll go for a drive. The headlights are on. The tail lights, I need to go through and diagnose the right side. Something's not working. Turn signal bulb. And it's usually just little connections. There's no big issues with headlights and taillights. Go for a drive, make sure we don't have major vibrations in the drive line. Make sure that I mark all of the locations of our battery boxes, our motor, the cradle to the mount, because that needs to really stay in place. If you accelerate too hard and you put a twisting motion on it, that round clamp that is around our Hyper 9 motor could slip a little bit, and that would be very bad. So I'm gonna keep an eye on everything with my witness marks on my Sharpie. And here's our motor, very happy in its place. We have plenty of gap at the top, which is very important. We have our mounts, our bracketry holding the motor down to the frame of the car right there. And the front of it is cradled with a lip so that it won't go this way, and the back is also controlled with some of the bolts, but most of the force that we're trying to prevent, I think, is forward this way because there's a physical barrier. But there is a gap in the firewall here. Kept a gap because I didn't want, you know how sometimes the front end of a car can have a minor amount of twist when you're flexing the suspension. I didn't want the the battery box to chafe against that firewall or be too rigid, because I don't know, just in case there's some sort of geometry movement there. I didn't need a big brick kind of tacked up against everything, because it might stress and break a joint somewhere, or stress and break the aluminum on the box, which is probably the weakest link. So air conditioning stuff, yeah, I need to go through and evacuate and charge the air conditioning system. I'm nervous because that's another thing that I just did from scratch for the first time in my life ever, was crimp all of these hoses. I mean, they look great. Crimps look very professional, and I'm happy with them. Great. We have access to the steering box if an adjustment needs to be made. Braking system is there, the sway bars. I'll take you underneath, you'll peek at the bottom. I'll take another photo here, and we will say bye-bye. Thank you guys for watching. Thank you again for your Patreon patronage. And the next episode will be so that'll be a pretty good time there. Okay, toodles.